All right, ladies and gentlemen, hello and welcome back once again to a special episode of the Briefing Room brought to you by the folks at DM Radio. First, I can't miss a chance to promote our TV show, Future Proof. Check your local listings for the world's first made for TV webinar series. Future Proof is all about how today's technology designs tomorrow. We're in Washington, D.C., Atlanta, and a bunch of other markets, Pacifica, California. So hop on YouTube if you don't get it on your cable television. So it's finally time for real time. Yes, indeed, folks. I've been talking about real time data warehousing for about 24 years, and a lot has changed in 24 years. The speakers today, Chinmay Soman, head of product at StarTree, and yours truly, of course. I'm just going to talk for a couple of minutes here and basically say that I remember the earliest days of talking about real time data warehousing. In 2002, I published an article on dmreview.com way back then, and it was all about real-time use cases. Now, back then, you couldn't get a lot of concurrency. You couldn't really get true real time. And of course, real time has always been a bit of a question. What do you mean by real time? Is it sub-second? Is it inside of a minute? Is it every hour? It just depends on the use case. But what happened at LinkedIn a while back when this project was started is they realized there was nothing off the shelf that was going to do the job that they needed. Same thing happened, of course, with Kafka, with Apache Kafka. Also started at LinkedIn, is now run by Confluent, or at least overseen by Confluent for streaming first architectures. Very cool stuff. But in the topic today, we're covering real-time analytics, really real time. So why is Pinot so good at that kind of stuff? Well, basic stuff, columnar storage. It stores in columns instead of rows, so it reduces I/O. And of course, rows compress much better than columns because theoretically the data is all the same in a particular row. It's very good at different kinds of indexing. It does partitioning across multiple servers to what? Allow parallel query execution. Segment assignment and intelligently assign segments to servers based on factors like data size and query patterns. So you can see it's optimizing how it does things based upon usage. And that's what you want to see these days. Query routing, pre-aggregation. What is it good for? Stopping hackers. That's a big one. Fraud detection, really important. It's good in the payments industry. I learned from my buddy Hyon Park today, who said he'll check out the archive of this particular show. It's very good for scanning financial transactions at scale. And let's face it, if you want to stop a financial fraudster, it's best to stop them when the fraud is happening. It's not as good to stop it after the money has been taken away. So Apache Pinot is very good for the payments industry for being able to monitor payment activity in real time and massive amounts of payment activity. Strange things happening. Let's take a look. Really strange things happening. Let's stop that transaction. And you want to watch out for the false positives, of course, because they hurt customer experience. What it's not, well, it's not a multimodal database. It's not ACID compliant. So it's not great for complex joins either, though it does support joins. So again, purpose built, horses for courses, as my co-host Jim Erickson used to say many years ago. Know what you're using this thing for, and you don't have to do it yourself. Bring in the big guns. And with that, I'm going to hand it off to our friend over here. Go ahead, Jim.
Awesome. Thank you, Eric, and thanks for having me. Let me
I
start.
realized I didn't even share, did I?
It's all good.
Spaz. All right, go ahead.
All right.
Take it away.
Okay, there we go.
Chinmay's got all the good stuff anyway, folks.
Yeah, thanks for setting the stage. I appreciate that. I'm gonna step back a little bit, talk about some of the context for why this was built, and then go again deeper. And then this is more or less what we'll cover, right? So start with the analytics landscape. Where do we fit in, and where the industry is essentially moving towards. Quick intro to Pinot and StarTree, and then a super quick demo on what you can do today. And then we'll really focus on one important vertical use case for this technology, which we'll get into in the later half. All right. So, in the traditional analytics, whenever companies, the big companies, when they talk about analytics, it's more or less in the realm of a data warehouse, right? You have your internal analysts and operators generating insights on terabytes or petabytes of data, and then you're generating these reports on a daily or weekly basis. You can also be doing ad hoc analytics. Something going wrong, you want to go dig deep into why it happened and do some triaging. In the recent few years, though, right, what we are seeing this trend of moving from these internal analytics to more powerful user-facing analytics or user-facing insights. Now, this is very different, right? Where the insights are directly given to all of your users and customers, right? So now you're going from tens of analysts to millions of users effectively doing the same kind of queries on your database. So now the scale has grown, tenfold or more. The complexity is more or less the same, and the query latency required is much more stringent in this case, right? So let me give you some real world examples of where this is being used today. As you mentioned, LinkedIn was one of the few companies who really adopted this and monetized the ability to provide insights to their customers. The very first one was, of course, who viewed your profile. Seems very simple. You're just showing insights on who has seen your profile, yeah, in real time and also historical. And it actually, although simple, it actually led to a huge increase in the user engagement on LinkedIn. And this was sort of the root of it all. They saw the success of this, and they wanted to roll out hundreds of metrics. In fact, any number that you see on LinkedIn today is actually being generated through a real time analytics database. A good example is the feed relevance, right? So if you have lots of content that you want to show, you want to make sure you're not seeing the same thing again and again. This is actually a use case of real-time analytics, where you want to see, has this user seen this content in the last 14 days or so? Simple query, but imagine running it on a database of 950, almost a billion users,
Mm.
which is tens of thousands of queries per second, and each of them has to be complete within 100 milliseconds, right? Otherwise, you're gonna suffer the user experience. Another great example is from Uber. With this, if you open your Uber Eats app, you actually can see what are the popular orders happening in your specific area at that particular time. And then the other good example is the Restaurant Manager app, which is given to all the restaurant owners across the globe. So about 500,000, half a million of owners are looking at this on a daily basis, and then they get a real-time view of what's missed, what's inaccurate, and so on. Both are good examples of analytics being done at a very, very large scale. And then if you look at what is the most important aspect here, there's actually two things that are critical. One is the ability to analyze an event as it's being generated. As you said, right? If somebody's getting scammed, you want to know right away. If somebody's looking for for some pizza, you need to know it right away so you can recommend the right things to the people. So the real time freshness is super important. At the same time, we also need to be able to crunch a large amount of historical data. So both are important when we are going to surface these kind of insights to the users. Now, this is a good way to analyze sort of all analytical systems, right? This is a sort of a quadrant where we have the x-axis, where x-axis denotes who's the audience of that insight, right? So whether on the left-hand side, it's the internal audience, right? These are your internal engineers, scientists, and operators. And on this side is the external users. So for LinkedIn, it's all the LinkedIn users. For Uber, it's all the Uber drivers and eaters and riders. And on the other axis, we have real time and batch, right? So we have where is the source of data coming from originally, right? Whether it's sitting in S3 or some data lake, or it's coming actually streaming in real time. And so with this, we can see where traditional analytics, they sort of are here, right? So you have large amounts of batch data, and then the audience is pretty much internal to the company. And so all your snowflakes of the world, your BigQuery, and even the legacy ones like Teradata, all those things are sitting here. And what we've seen is a shift in this direction, right? So both making the data more fresher. So you go still internal analytics, but for more real-time data. And then also in this direction, which is I want both data freshness as well as being able to high concurrency. So being able to surface this insight to all of my users, not just internal users. And that really is the whole spectrum of real-time analytics, right? And then a special case of real-time analytics is the user-facing analytic, as I mentioned. That's the most complex problem to solve in this realm. All right. So now I can, with that, I can introduce Apache Pinot. Apache Pinot is actually built for user-facing analytics from the get-go. So the who viewed your profile and all these other metrics that you see on LinkedIn are being powered by Pinot. It is as Eric already mentioned, it's a distributed columnar database that's designed to ingest data from all kinds of sources, streaming like Kafka, Kinesis, PubSub, or batch, the data sitting in S3, or even HDFS. It can ingest all of that, and then you can build all kinds of powerful use cases on top of Pinot. And as we'll see, it has a lot of important features around query optimization, pre-aggregation. Indexing is a very inherent component of this, which gives us the speed. There's sort of three, if you have to compare Pinot with the traditional analytics, the three dimensions which are very important. The concurrency, the query, how many queries per second can you run on this? This is important if you're going to power your user-facing analytics. The data freshness, so how quickly can you generate an insight as soon as the event is produced? And then, of course, the query latency. How fast are your queries? So if you look at data warehouse, the freshness typically was in days. Now it can be in the order of hours or sometimes minutes. Whereas in Pinot, you could actually do sub-second. So as soon as the event is produced, within milliseconds, you're actually able to query that event. Query latency is typically it's in the order of seconds or minutes, right? So there's a human sitting in front of a query console waiting for a response. Whereas with Pinot, it's most of the cases, it's machines that are querying Pinot and surfacing it in some application. So latency has to be within milliseconds. And then concurrency, as I mentioned, right? It used to go from single-digit users to now we have hundreds of millions of users. We have cases where one cluster can power more than 200,000 queries per second on Pinot. This is a good visual of how to compare the two analytics, right? It's actually not, they're not meant to be compared. It's almost apples to oranges, right? They're solving two different use cases. But just to put things in perspective, right? With StarTree, just within StarTree, so not all of Pinot, just within StarTree, it took us only 4 years to hit 1 billion queries per week, which Snowflake took 10 years across all their customers to it, right? And the cost per
Wow.
query on Pinot is significantly lesser than something like Snowflake, right? Now, if someone looks at it and say, okay, Pinot solves all my problems, it's not meant to, again, replace Snowflake. That's not the point. But the point here is there are some cases that Snowflake is not able to solve, especially user-facing analytics. And that's where Pinot and StarTree, they come in. Just to highlight, Eric already went through a bunch of differentiators, including indexing. So you can, there's various indexing technologies, inverted index, sorted index. You could have an index for JSON data, or even for text columns. And we even have a special index called StarTree index, which is kind of like a materialized view. So you can pre-aggregate some data based on your table, and it can surface that. In addition to all of that, Pinot, one unique thing about Pinot is its ability to do real-time upserts. This is very critical, right? Especially, I come from Uber. This is one of the main use cases in Uber, where we used to look at the real-time insights and then use that to make power some decisions. And that could be either financial incentives to the drivers or to even modify the supply-demand ratios on our side. So it was critical that the data is accurate. And the only way to do that is to support real-time upserts, deletes, inserts, right? So, as you would know, the real-time stream, the data is not that great. It often has duplicates. It will have data, some updates to some old records. It will have deletes. So unless you can reconcile these, your queries otherwise will not be accurate. So this is one of the most important things. Pinot is the first open source database to do this at scale. And that's one of the main features why people are adopting Pinot. The other one is semi-structured data. So imagine having a JSON column, which you can, do filters, group by, aggregations within milliseconds, right? That's something, another powerful feature Pinot supports through its JSON index. It comes with a SQL interface, as we'll see in a demo. It primarily built for OLAP queries in real time, but it can also do these other things, as you mentioned, joins, window functions, complex table expressions, and so on. And finally, we recently added a way to extend Pinot with cloud storage. So you can have all the important real-time data stored locally in Pinot, and the historical data can be sitting in a cheaper cloud storage like S3. And you can seamlessly query it through Pinot. And there's various optimizations where all of this can still be done in milliseconds, even if the data is sitting remotely. And then, we have a growing system of integration. So there's all kinds of data sources that we support today where you can ingest data locally into Pinot, from likes of, Kafka, to Pulsar, Red Panda, to even things like Snowflake. So there's a way to get a subset of your Snowflake data locally hosted in Pinot, and that's a good way to accelerate queries. And many of our users are actually doing that. They have a warehouse, which they're perfectly happy with, but there's a way to complement their existing warehouse with Pinot for their critical use cases. So if they have their user insights or clickstream that they want to, run thousands of queries per second, it's very difficult or cost prohibitive to do it directly on Snowflake. That's where you would bring in something like Pinot.
Yeah, can you dive into that a bit? What does that look like architecturally? How do you actually effect that change? Do you do an export from Snowflake? Do you just hit the Snowflake API? How do you actually do that?
Yeah. Yeah, good question. So Pinot has an asynchronous compute capability, which sits alongside the main cluster. And that's where we run some of these data processing jobs. So the job is actually hitting the Snowflake API. So all you do is point to the Snowflake table, give the Snowflake credentials, and it'll actually fetch data from Snowflake.
Hmm.
And it can do both one-time fetch, or it can do an incremental fetch. So every day you can schedule a fetch where, like, every day go and fetch the latest updates,
Hmm.
based on some time filter to keep the table in Pinot in sync with Snowflake. And same thing works with anything really. We have a Delta Lake integration where you might have a Delta Lake table, and you can actually import that into Pinot and then query it. And then, of course, queries on Pinot would run much, much faster.
Yeah, that's interesting because it's a more I guess a richer analytic architecture. You've identified, hey, this one set of data, maybe it's user behavior or something. You really want to be able to allow your users to query this stuff. And so what you grab it like once a day or once an hour from Snowflake, populate it into StarTree and allow this just massive analytical capacity to run very inexpensively, right?
That's right. That's exactly right. And as you notice, we're not improving the data freshness here. Data freshness is the same as your warehouse, but we are accelerating the other dimensions, which is concurrency and query latency. And
Hmm.
and many companies would actually start with that model where they don't even have Kafka. You'll be surprised how many people don't run Kafka even now, or some sort of a streaming technology. It doesn't have to be Kafka. So they're still stuck in the legacy land of, data comes, there's a massive ETL that happens, data sits somewhere in a data lake, or even legacy technologies, and but they still need to serve some use case at scale. Those are the good examples where they would bring in, import data from a lake to Pinot and then accelerate queries. And over time, then we see them moving to more streaming architecture. So once they see the value in this, they would then say, okay, let's now also improve data freshness. And then they bring in Kafka and other technologies.
Hmm. Interesting.
Yeah, fascinating time to be alive. All right. These are some of the real world numbers of how Pinot performs in the field. LinkedIn, of course, one of our big use cases. A single cluster does 5,000 plus metrics on the website. More than 200,000 queries per second on Pinot. Stripe is another good example. Stripe is using, as I'll explain later, it's using for actually internal analytics. They're building a metric store on top of Pinot. So
Hmm.
all their fraud metrics, usage metrics, merchant dashboard metrics, they're all sitting in Pinot. Every single transaction is actually going through Pinot to generate those metrics. So massive scale of ingestion, do more than 20,000 queries per second and at a very strict query latency. And then Uber is another big example, right? It's using it pretty much everywhere from internal, external analytics. And they are a big user of upserts. As I said, Uber was one of the first ones to really use the accurate query functionality of Pinot, which is unique.
Hmm.
And there's many, many others, right? There are 1,000 plus companies using Pinot in production across many
Wow.
verticals, right? Retail, fintech, so Stripe, City, WePay, they're all Pinot adopters. Most of the food logistic companies, almost all the top food logistic companies are actually using Pinot, like Uber, DoorDash, and then in other parts of the world, Kareem and Blinkit and Swiggy and so on. They are pretty big, massive adopters of this technology.
Hmm.
And then, of course, the community is still growing. Got 11 million Docker downloads and 5,000 members.
Hmm.
Let me quickly talk about StarTree. I don't plan on going in too much detail on the StarTree side, but it is we are providing a fully managed experience around Apache Pinot. So it's a cloud native hosted service for Pinot. And the goal is to really make this StarTree as a focus on cost efficiency, making it faster even than Pinot than the open source Pinot, and then reduce the time to value. There are lots of things, as we'll see in a quick demo, where you'll be able to move things much faster in the StarTree land. Right.
Hmm.
So let's switch to. I'll give a very quick view of what StarTree is. Right. So this is one of the tools that you get when you sign up for StarTree Cloud, which is called Data Manager. It's very easy to sort of create a new data set. You can click on whatever you want, whether if your data sitting, let's say in Confluent Cloud. You just select. Um, it'll tell you what topics exist in that particular Confluent Cloud connection. And one important thing that we do here is the data modeling. So it'll actually fetch real data from Confluent in this case, and then you can do data modeling right in this tool before any table is actually created. Right. So this is all in preview mode, where you can go and look at your schema, look at the columns that it's ingested, and then it's also you're also able to do derived columns on the fly. So you can do, for example, if you have a nested JSON, you can actually flatten that out using by adding a new derived column on the fly.
Hmm.
Right, so lots of things that you can play here, including adding new indexes and then repartitioning the data. You mentioned partitioning. You could actually change how the data is partitioned here, whether you want upserts enabled or not. All those things are you just click through all those things. And then once you have the data ingested, you can just query it something like this. So you get a query console in StarTree. You can do group by, order by, even join. Any of the join queries are also supported in StarTree. All right, let me go back in the interest of time. If you have questions on this, I'm happy to switch back to StarTree. But I want to dive. We spoke about user facing analytics. That's where Pinot shines. Um, the other aspect is the internal real time analytic. This is also pretty important for a lot of companies, right? And then the good thing is, as a company, we are focusing on both user facing as well as internal real time analytics. So what does this mean, right? For internal, observability is a great use case for internal analytics, and this could mean monitor your business, right? How your business is doing in real time. It could be monitoring your systems and applications. or do anomaly detection. That's kind of your business observability as well. And these are real world examples that people are using Pinot or StarTree for, right? So Stripe on one of their Black Friday last year, they built this
Wow.
dashboard, which is very cool. So Black Friday is one of their major events for Stripe, and they could track exactly how many transactions, the monetary value, where are they coming from, all those metrics
Wow.
directly in real time on Pinot.
That's
So
crazy.
very, very cool. They did publish this on LinkedIn. And again, the QPS and latency is off the charts here. Another big one is anomaly detection. So we actually have a tool called StarTree Third Eye, which lets you detect multidimensional anomalies in real time. So if your order volume spikes up or it drops, right, or the number of trips happening in Uber, they suddenly change, you're able to detect that and also do root cause analysis, like which dimension caused this metric to go up or down. All of that is actually possible with Third Eye.
Hmm.
And then something like risk analysis. This is the example you cited, right? A major global bank is actually using StarTree for exactly that purpose. So the events come in through Kafka, either these are login events or clickstream events. And then they have a risk model where they generate these user attributes and then evaluate that in real time, whether to approve or deny that transaction. It's not exactly synchronous, but it is still happening in sub-second latency. So all of that is great, but one new emerging area in this space is the systems observability, right? And I say new, but of course, it's not, companies have dealt with this problem for many decades, right? People use Datadog for monitoring all of their metrics from various, CPU memory, all of their microservices. Datadog is actually a great product today for doing things at scale, along with others like Prometheus and other solutions. But what we saw is all these solutions, they are really an all or nothing stack, right? So they come with, send us your data and we will provide a visualization on top, which is perfectly fine for certain scale and use cases. That works just fine. But for some of the larger use cases, it does provide limited. There's some issues with it, right? The stack itself, the whole stack may not be efficient. You may have a good agent, but may not have an efficient storage system.
Hmm.
So your cost might go up. That's one. Or you may be, you can't build anything else on top. So if you send your, for example, if you send your data to Datadog, you can't build a user-facing application on Datadog on the same data. That's not possible today. And then, many of companies actually are moving into a disaggregated view of the world, right? So instead of a monolith, people do prefer the flexibility of choosing their specific choice of components in this stack. A good example, an analogy would be in the olden days, you used to get an all or nothing monolith for warehouse, right? And then, over the years, people started building their own data warehousing stack. They chose Hadoop as a storage system. They chose a particular query engine for sitting on top, or a particular metadata repository, and a way of doing security that fit their business needs. We believe systems observability especially, is sort of heading in the same direction. Instead of an all or nothing monolith, people want to be able to pick and choose their choice of technologies. And as the vision that we have is StarTree can be the storage and query layer for in this stack, right? And we are seeing some early success. So companies like Uber and Cisco are already moving in this direction where they have petabytes of data sitting in Pinot for their metrics, logs, and traces, right? And so this is really for people who are very cost conscious. Their Datadog bill might be very high. This is one of the main reasons. And on top of that, they have their own choice of technologies, own security or data governance needs, which is where they want to customize all these things. And that's where we are positioning it as a disaggregated solution.
Yeah, I'm glad you brought this up because as I was listening to you talk earlier, I started thinking to myself about companies like Splunk, for example, which is now part of Cisco. And in the world of Splunk, you're looking for metrics, logs, and tracers, and there are tons of them. There are just absolutely massive amounts. So to be able to put all that data into a solution like Pinot and then be able to query it with machines, rapid fire queries
Right.
on all these different things, especially, and you talked about third eye, would that be capable at root cause analysis, for example? Because that's really what you're doing in a world like cybersecurity is you have just mountains of information flying at you all the time. You're trying to correlate these things and look for patterns and look for dependencies, basically. What
Yep.
is triggering what? That's root cause analysis. Is that
Yep.
something that Third Eye can help with?
Yeah, that is the vision, right? We are early in that game. Right now, Third Eye focuses exclusively on business metrics. But yes, this is exactly a good use case of, once you have a disaggregated stack, yes, I should be able to plug in Third Eye here next to my visualization layer. So you can
Hmm.
have your Grafana plugin and your Third Eye sitting on the same platform. That's the beauty of disaggregation. And then Third Eye can do exactly, you can detect anomalies and also tell you do correlation analysis on why did this metric go up or down. My CPU spiked up. What happened? Right? Was there a release? Was there some dimensions that you want to like some maybe on the metric tags level that you can do root cause analysis on? So yeah, that's
Right.
perfect. So that's really the idea, and this is an example of how a typical deployment may look like, right? So, today you have tons of these agents. You have hotel agents, you have vector agents, or heck, you can even use a Datadog agent, right? You can choose whatever agent you want that fits your needs. You can choose something like Kafka as a collection system. And it doesn't have to be Kafka, but Kafka is a popular choice for collecting these metrics, logs, and traces from various
Hmm.
applications. And then you can also choose, either use Grafana or Tableau, whatever you prefer to query and visualize that data. And then, of
Hmm.
course, all that the goal is to make sure we can integrate with this stack, right? And then make it the value proposition is to lower the cost of real time observability. That's really the primary value proposition, right? And
Hmm.
and this is why we think StarTree is uniquely placed to handle the storage and query layer for observability. And then one thing to know about observability is, right, there are many dimensions to this. One is, of course, the data volume is very, very large. Even smaller company like 10-day-old startups are still generating terabytes of data. And they want to be able to analyze those logs in real time. Like what just happened with my user? All right. They want to do anomaly detection in real time or fraud detection in real time on those logs. Then many of those events are actually just hidden away in their logs. And the other thing is data governance. A lot of these companies, they don't want to be able to send some sensitive logs out to somebody else. And that's where the data security and governance comes in. So with StarTree, we think there are three main benefits of why this may become a compelling solution for your stack. One is Pinot itself, right? We have a great query engine for which already can handle terabytes to petabytes of data, lots of indexing technologies. In fact, we even added a bunch of new things for observability, which is Prometheus data format support. So
Oh, right.
you can send data in Prometheus format, and we can already we know how to ingest that. And then Pinot added a new encoder for logs. So CLP is a new technique for compressing logs, and this is phenomenal. So Uber published this article on they're getting almost 150x the compression of the raw JSON logs,
Jeez.
and after that they hit a 1 petabyte storage. So you can only imagine how big the raw data is, right? And
Wow.
then also lots of optimizations on how to handle map data types. How do you do JSON indexing, JSON queries quickly on all this data, and so on, right? The other thing is tiered storage. This is an important thing to reduce cost. So you can say for metrics and logs, my 1 week of data is very important. So store that in local Pinot. everything else can be in S3. So you can still query that data, but your latency would be higher for the historical queries, and you can have millisecond level queries for your local data. So you can really, you get to tune how which are your important queries, which are your non-important queries, and you can lay out your data accordingly.
Hmm.
And then the last one is BYOC. So this is our deployment model for StarTree. The guiding principle is really no inbound access to the customer environment. So once it's deployed, we the it's although it's remotely managed, we do, there is like fully secured in from our cloud. So the way it works is for many of these security conscious customers, the entire stack is deployed in their cloud account. So it's not a SaaS. It's although it looks like SaaS, it's actually sitting in their AWS or GCP account, and we are remotely managing it. So it gives them a lot of flexibility. It gives them what choice of hardware they want, whether they want to apply their cost savings plan, any custom agents they want to run, or data governance they want to do. All of that is actually possible through BYOC. So BYOC stands for Bring Your Own Cloud. That's
Hmm.
one of our deployment models. And yeah, and then this is the tiered storage that I was talking about. Right? So you can tune. This is my sensitive area, and this is my non-sensitive area, and then all you need to do is configure this age, and Pinot will automatically move anything that goes beyond this age. It'll automatically move it to the cloud.
That's wild. So basically, there's a built-in engine where you say, okay, every 48 hours, that's my window that I want real-time access. After that, just automatically move it into this other cloud. So you don't have to worry about making sure you execute on that. It's built
It's
into
built
the
in.
runtime, basically, right?
Yes, exactly. And you would not notice it except maybe if the query hits anything here, the query will return slower. From the application side, it's all seamless. And the one just to add more to this, one thing we realize is although all your raw data might be sitting in S3, very, very rarely do you want the raw data. Many times you are only using that as a filter or a count or some sort of an aggregation. So we have a way where you can actually store Bloom filters locally for data that's remote, or store a materialized view locally, which is our StarTree index, when the actual data is remote. And then all these things are dynamically generated. You can decide after the fact, I forgot a Bloom filter, or I forgot a StarTree index. You can always go back, add it to the data, and cache it locally. So the queries that hit these filters and indexes, they are milliseconds, whereas the data is actually in S3.
Hmm.
So all these combined, as I said, you get to we have the scale out way of ingesting petabytes of data. The indexing technologies accelerate queries, and then tiered storage can help you lower your cost, and BYOC really gets you the data governance angle for observability.
Hmm.
So that's all on the storage and query side. But on the for being able to visualize, we're actually investing in Grafana. Right? We're choosing Grafana as the first thing to showcase this. We're still early on this, but the vision is to provide these different dialects in Grafana. So you can have PromQL for visualizing metrics, LogQL for logging, and then TraceQL for traces.
Hmm. Very cool.
And then I
Yeah, I
can,
mean, I
yeah,
was
go
just
ahead.
going to say that one of the real challenging parts of that world is that these are very different things.
Yes,
Metrics are very different from traces, which are very different from logs. And, the log analysis in and of itself, I can see where something like StarTrue would be very powerful because you're looking for disparities in logs or patterns
right.
in logs, for example. And there are so many of them. So to be able to do this rapid fire querying on that kind of information would be very useful to someone who is, let's face it, kind of spelunking in the dark, right? That's what you're doing when you're trying to align these various developments that are happening at speed and at scale. That's a
That's
very
right.
difficult challenge, right?
Yeah, and to add to that, right? It's one thing for humans to quickly be able to find it, and it's an entirely other thing if you want to now productionize that. If you want, like, okay, I found this insight in my logs, great. Can I put it into an application in front of my users? That's a whole
Hmm.
then now suddenly you're talking about, if you have 1 million users accessing that, now you have,
Right.
at least 1,000 queries per second hitting your observability stack. And
Right.
and that's where we are, positioning Pinot and StarTree as. All right,
Well,
let me.
this. Oh, go ahead. Yeah, go ahead.
I was just gonna give you a quick demo on the
Okay.
thing that we built so far. So this is actually a Pinot table, and connecting through Grafana. So it looks like any other Grafana dashboard. You have your cumulative records. You can filter by various dimensions. Let's actually go into one of these. So these are sort of website views that we have broken it down by browser, by country, and so on. Right? So let's take a look at one of these. So inside you can, PromQL is something we are experimenting with. It's still early, but right now you could actually do PinoQL today. You can, play around with whatever aggregation function you want, or order by, or even add more filters. So let's say this is the view of my website views by country. Let's say you want to filter it down by do this when browser is Chrome, right? And it will immediately give you
Hmm.
the change perspective. Or you want to do Chrome and Firefox, what are the views? So as you can see, you can, play around with this very Grafana-like interface to actually do Pinot queries. And then this plugin
Hmm.
can also show you the real Pinot query that's happening on the underlying database. And so as you can see, this is very, very powerful. So you can actually do a join query here directly. You don't have to use this limited interface. You could do whatever window function or join query you want directly, and then visualize that data directly in Grafana.
Hmm. That's great. The ability to see what's happening and to very quickly iterate, add filters, subtract filters, expand the view, whatever the case may be. That's all facilitating a very fluid analytical process, right?
That's right. Cool. And then, uh, just to summarize it, we're pretty much done. I can take questions, but it is, what we are shooting for is flexibility. So we want to build one platform that can do user-facing analytics that could also power your internal observability, whether it's business or systems. Very focused on cost efficiency. Right? This is obviously, especially in today's times, cost is a big deal. No matter if you're a small company or even for very giants, they're all trying to save costs. So things like tiered storage, BYOC, this gives you the levers to lower the cost of real-time analytics. And then, of course, the bread and butter for us is query powerhouse. Right? It has to be. That's where we continue to invest in new indexing technologies to improve the speed and overall throughput for the queries. And then
Hmm.
finally, we do have a free forever workspace. So anyone wants to try out StarTree, all they do is register and they get a permanent workspace that we don't delete. You
Hmm.
can go do that at s3.ai/free.
Very, very cool. I've got a few questions for you. When I think
Yes.
about you talk about this disaggregated stack, which is very interesting because it kind of refers to a modular design and being able to use different component parts in different ways. I mean, that was the vision 25 years ago with service-oriented architecture, right? With fine-grained services and coarse-grained services. Then Kubernetes comes along some 20 odd years later and dominates the market. It's not like SOA exactly, but it's
Correct.
the same principles, right? Is that about
Yeah.
right?
Yeah.
That the idea is that you have component parts that you can then plug in almost like aftermarket engine parts or something.
That's right. It is kind of like almost like OEM,
Mhm.
or some sort of a modular. It is modular architecture, right? Where you can, I think the prerequisites there are the communication standards. That's
Hmm.
important, right? Once you have these standards, then it makes it easy to plug in all these components. So I'll give an example, right? So if you look at the left-hand side, right? Hotel is becoming a standard in this, right? So anyone talking hotel now can plug in into this ecosystem. Kafka is becoming a standard, right? There are many. I mean, Confluent itself doesn't run Apache Kafka anymore. They have already built their own completely new system, right? Which it looks like Kafka, it talks like Kafka, but it's not Apache Kafka.
Mm,
So Kafka is now really a standard. So if all this data could actually flow in a Kafka protocol, it makes it easy to plug in. For example, Red Panda also supports Kafka protocol. So
right.
anyone who talks Kafka can easily plug in their metrics, logs, and traces in this. And same thing with StarTree. Same thing on the visualization side. If you are PostgreSQL compliant, you can connect to a whole wide set of BI tools out there.
Yeah.
Same thing with JDBC. So as long as hopefully can pick a few standards and then abide by them, I think then this disaggregated stack becomes really powerful.
Yeah, that's it. What was the old joke about standards? The nice thing about standards is there are so many of them, right?
Yes, like I think the joke was if ten people come together and try to fix the standard, they come up with like one new standard. That's why I said hopefully. I don't think we will ever pick one standard, but hopefully not more than 10.
Right. Well, it allows for organizations to focus on their particular value add, right? If we
That's right.
accept certain standards, HTTP is one of the best ever, right? Hypertext Transfer Protocol, still rocking and rolling today, right?
Yep,
Still good stuff. Yeah,
absolutely.
yeah, that's interesting. And then, I was looking at the different file formats that it supports, and I remember learning about Parquet and how Parquet is a analytics focused file format, right? Because in the beginning of the file itself, you have sort of a summary block that says what's on this file. So the whole idea of Parquet was to have a very analytics friendly file format. Is that correct?
That is right. So it's a highly compressed. It's also columnar. So just to give you an idea, if you have, let's say logs, right? If you have 100 gigabytes of logs data, pure in JSON or text format, let's say JSON, right? It can actually compress to, up within below 10 GB in Parquet or Pinot file format, right? So
Wow.
columnar compression is very important. You can, I mean, what at the heart of it is something like dictionary encoding, right? You can have instead of repeating the values in every row, you just repeat the actual ID of that text, and that's how you get the compression. And
Hmm,
there are many such techniques that can compress a format, and it also summarizes, right? So within that file, what is the min value and max value for my columns?
right.
If you're using it for filtering, you don't even need to scan the data. All you need to do is get the column metadata. Many of those techniques actually Pinot has adopted. For example, we don't use Parquet format. We have our own format, but this metadata is actually available in a central place. So without even touching the data servers, we can actually prune some of the segments already. Some of the files we don't need to touch based
I
on the
see.
and that's a big reason for getting query speed. For example, if you have your data partitioned on a certain dimension, let's say user ID, and you expect a lot of your queries will have user ID as a filter, then that makes it very powerful. Then you can actually narrow down for this query, I will find my result in this particular partition 13, and then
Hmm,
only look at the segments relevant for partition 13.
hmm.
Right. So
Yeah, that's pretty clever.
the metadata optimization helps us a lot in improving query speed.
And how much of that is dynamic? I mean, it seems to me that a lot of what's happening under the covers here is dynamic. So it's watching for query patterns, for example. Does the system then alert you to possible changes, or how does that actually work that you optimize the architecture, whether it's for storage or for query performance? Like how much of that is dynamically generated versus manually executed?
That's a great question. So let me start with ingestion, right? Data ingestion. The way ingestion happens in Pinot, and let me go back to one of these slides, is for every incoming piece of data, let's say real-time Kafka topic, right? It's generating these Pinot segments, which looks like Parquet essentially, right? And then it will seal that segment at some, let's say 100 GB or whatever, 1 million rows. It will seal the segment and then create a new segment. Now, what's interesting is the size of this segment. If you have too small a segment, um, you know, it will actually, you will have to deal with, a lot of small file problem. So tuning the size of the segment is pretty important. The number of partitions. that's pretty important as well. How quickly can you parallelize and ingest this data? Both these things we actually do tune dynamically at runtime. It's not
Hmm.
automated. You still have to manually tell the system on what change to make, but once it's a simple config change to dynamically change the size of the segment. Same thing with querying. Let's say you start off in your query console, right? You start off by executing some queries and you get your it gives you a lot of stats on especially these ones right here, right? So for example, these number of documents were scanned in this query. And then these number of scanned in filter. So it's actually
Oh,
telling,
wow. Wow. You get all
um,
that data. I see. Yeah.
yes, for every query you get all this data back.
Wow. That's
So
great.
you right away you can tell that, hey, my filtering is very inefficient. Um, Obviously here there's no filter, so let's assume there was a filter here. I can then say, okay, I can then add an index on whatever column is being filtered, and that should drop to, that should become much more efficient. So there you can use this to optimize the query latency.
That's
What's what
great.
we do, we have coming up in the time frame of Jan or Feb, we will actually add and optimize auto tuner for queries. So it can automatically look at these things and recommend like, hey, you need to add an index, or you're doing a lot of JSON queries. You don't need to. You can actually go back, create a derived column, so that
Oh,
you move the complexity from query time to ingestion time, and it
wow.
will dynamically generate that column for an existing table.
Wow.
So all those things are actually they're coming up. So it's possible to do it manually today. It will be automated soon in the product.
That's very, very cool. And I'm thinking to myself, you mentioned these JSON indices, and JSON, of course, can be very bulky, but there's a lot of useful information stored in JSON. Think about like a retailer, for example, being able to query a database like Temu or Shine or one of these
Yeah.
e-commerce sites by color and by other dimensions. That's a very interesting use case. Like, let's say you have your favorite color is purple and you just want to buy purple stuff. Right now, most e-commerce sites will not let you search that way. It's hard. I mean, some of
Yes.
them do, but that's
Yeah.
a pretty cool feature. And if I hear you correctly, you could even notice that becoming prominent and make it a derived column. Is that right?
Exactly. Exactly. So at the in the in the query you can do something like JSON match, um, and then here you can write either dollar, let's say, payload dot color, something like that, right? Color equal to blue, something like this. You could do this at query time. What
Hmm.
it's going to do is it's going to parse the JSON and then give you the answer, which is slow. You could also do JSON index. So you can actually, in that dynamic JSON, it's going to index all those different fields, and then it will accelerate query processing. But guess what? The trade-off is you're now the storage cost is higher because you're now also storing a bulky JSON index alongside your raw JSON column. Then the other thing, that's what you mentioned, right? So let me go back
Hmm.
here. I can show you one of these tables which actually has that. Uh, Let me show you a table config. Right? So what you could do is then create a derived column, something like this. So what this is doing is at ingestion time and dynamically, it can actually extract one of the fields in your JSON column
Oh,
and create it as a separate column. So
interesting.
so now this country, although it was in the nested JSON, is now part of your schema. So if you
Hmm.
look here,
Wow.
or even actually even here, you'll actually see country and state. These are derived columns and is materialized in every single segment. So any query that looks up country or color or state is now significantly faster because
Wow. I mean, that's cool because, in the old days of data warehousing, I joked about this recently, like 20 years ago, you had to really think through your use cases and what queries are going to be coming down your way. And you'd have to think through what that schema looks like. And once it's done, you leave it alone. Like you are not going to go change in that schema. And that,
that's
that
right.
I think is one of the real benefits that Snowflake came up with was was A, separating compute and storage, but B, they figured out, look, we want to be able to pull this thing down, change the schema, and then spin it right back up
Yes.
quickly. And that
Yes.
was a tremendous value because guess what? Every time in the old world, someone would think of after, oh no, I want to add this dimension, I want to add that dimension. It's like, no, you're not.
That's
Like,
right.
just
And
figure out a
I'll
way.
I'll add one cool thing to that, right? So I mentioned StarTree Index, which is really our that's one of our secret sauce, right? That's how our company's named. What it does is, let's say you want to build an aggregation on select, let's say, count of events, group by session ID, group by country, which is kind of like a materialized view. So what StarTree Index will do is, instead of materializing everything, it will split by those dimensions and then materialize at every different step for some part of the data. So it's not an entire materialized view. So it gives you the speed of a materialized view, but not the storage cost of a materialized view. And it's dynamic. So let's say you forgot to add a starting index, you could actually add one or many of those, and then depending on the query, it will pick the right StarTree index automatically.
Wow.
So that's the dynamic nature of this, which I think is very cool.
Yeah. Well, that is cool because anytime you roll out this kind of system and because you are specifically focused on user facing analytics, so it's great for software as a service, for example, for
Yes.
companies that have 150,000 clients, for example, and you want to be able to allow them to play with their data. I'm a digital marketer, so for me, a big use case is around understanding which topics are interesting to the audience, on what keywords matter, for example, things of that nature. But then even honestly, and this is kind of a complex one I'll throw at you, understanding what's going on under the covers with the statistics that you see. And things are
Yeah.
changing right now. I think it's because of agentic AI, quite frankly. I think that Gmail and Yahoo and Microsoft and some of these other guys for email marketing, for email distribution, are really kicking in a lot of these agents to test links and make sure it's not phishing and all this kind of stuff. So what I
Mm.
see is, oh, there were 7,000 clicks on this email, and I'm like, there were not 7,000 clicks on that email. All right, there's probably like 400. But being able to get to the bottom of that,
Yeah.
that's where this kind of technology could really come in handy, right?
That's a great use case for third eye. Like, where are all these? You can actually, that's exactly right. Right? Suddenly you notice a spike in your clicks. Third eye will detect the anomaly, and then you can root cause on which dimension, where did it come, which country did
Right.
it come from, which browser did it come from, and
Right.
then you can quickly get to. I wish I could show you a demo right now, but maybe some other time. It
Yeah.
does within seconds. You can figure out, oh,
Yeah.
it came from this particular agent, like from this country, from this IP. You could easily narrow it down.
Interesting. See, because what I noticed looking at the data was if I looked at all of the data, you can look at the entire string of like all these events basically. And I grabbed all those events, I loaded them into Google, I did it, into a spreadsheet basically. And what I noticed it was Windows machines and Chrome. I'm like, oh, okay, there's something going on in the Windows
All right.
machine because you probably know this. I mean, the set of steps to go from me sending an email out to all these people getting those emails is incredible. I mean, the amount of
Yes.
processing necessary,
Yep.
all these little switches have to be flipped and it goes all the way through. And, if your DNS settings are off and your spam roll is going to go up and all this stuff is very, very, very complex. But to be
Yep.
able to unwind that and then optimize for it and know, okay, and that's something that's really on the vendors too, right? Because the vendors will be able to identify that and then optimize and go, aha,
Exactly.
this is a fake click. Let's go ahead and pull that out of the report so they get better accuracy because who needs data if it's not accurate, right?
Absolutely. Yeah. That's exactly right. Yeah. Plus one.
Well, there you go. Well, it's been absolutely wonderful to talk to you today, Chinmay Soman from StarTree. Very, very cool stuff, folks. The disaggregated stack, observability, the ability to ask tens of thousands of queries every minute. I mean, that's very, very good stuff. And it's a complement to the warehouse. It's not going to replace the warehouse, but it's a very, very good, cost efficient complement, especially for user facing apps. We do archive all these webinars for later viewing. If you want to be on the show, send me an email, info@insideanalysis.com. That comes right to me. And we'll talk to you next time, folks. You've been listening to The Briefing Room. Take care.
Thanks all.